In this lesson, we are going to be graphing a parabola using vertex form. Vertex form is written in the equation y equals a times the quantity of x minus h squared plus k. We're going to be following the same rules that we've learned for our a value in previous lessons. We know that if our a is greater than 0, our parabola is going to open up. And if our a value is less than 0 or negative, our parabola is going to open down. Also, we have learned in the past that if our absolute value of a is greater than 1, our parabola is going to be narrower or skinnier. And if the absolute value of a is less than 1, or a fraction or decimal, our parabola is going to be wider or bigger. So from vertex form, the coordinates of our vertex is going to be hk. Now I want you to notice in our formula or our equation, h is negative by default, but when you have the vertex coordinate points, it's a positive h. So remember that when we're graphing later. And then the equation for the axis of symmetry is just x equals h. So in our first example, our equation is given to us in vertex form. Y equals 2 times x minus 1, the quantity squared, plus 3. Notice that our a value is positive, so we're going to have a parabola that opens up. Our vertex, remember, is at hk. And if you also remember, I said that the h in the equation is negative by default, so that is actually a positive 1, positive 3 for the coordinates of our vertex. And the axis of symmetry is just our h value at x equals 1. So the first thing we're going to do is just simply graph it how we've been graphing all along. We're going to plot the axis of symmetry at x equals 1. The next thing we're going to do is plot the vertex, which we know is at 1, positive 3. And the next thing we're going to do is plot a new point. So we know that we're already on the line x equals 1. So we can pick 0, we can pick 2, we can pick negative 1, we can pick positive 3. Any of those will work to plot our new points. So for my first point, I'm going to pick the value 0 for x because I think it's the easiest thing to plug in. So if we plug 0 into our equation above, we're going to get 2 times 0 minus 1 squared plus 3. 0 minus 1 is negative 1. Keep that squared. Remember to carry down your a value, which is 2 plus 3. So we know that negative 1 squared is a positive 1 times 2 and then plus 3. 2 times 1 is 2, plus 3 is 5. So our first point is going to be at 0, 5. 0, 1, 2, 3, 4, 5. And once again, we can mirror that over the axis of symmetry. So we're going to get 2, 5 for our mirrored point. We'll write that in here. So the next point that I'm going to pick is negative 1. And I'll write that in a different color so it doesn't get lost. So if we plug negative 1 into our equation, we're going to get 2 times negative 1 minus 1 squared plus 3. Negative 1 minus 1 is a negative 2 squared times 2 plus 3. Negative 2 squared is a positive 4. times 2 plus 3. So to simplify, we get 8 plus 3, which is 11. So our point is negative 1, 11, which is going to be up here somewhere. And if we mirror that over the axis of symmetry, we're going to get 3, 11. And then we draw in our parabola connecting the dots. And that's how we're going to graph them using vertex form. So moving along to our next example, we have y equals negative x plus 5 the quantity squared plus 2. Notice that we have a negative 1 for our a value, so we know that our parabola is going to open down. Our vertex is at the coordinate point x, or hk, and remember that our h is negative by default, so that means that in this equation, our h is a negative 5, positive 2, and the axis of symmetry is at x equals negative 5. So the first thing we're going to do again is to plot the axis of symmetry at x equals negative 5. And then if we plot our vertex, we are at negative 5, positive 2. So then the next thing we're going to do is plot some new points. So I'm going to get a little closer to our line, and I'm going to pick negative 3 for my first point. If we pick negative 3 and we plug it into our equation, we're going to get negative 3 plus 5 squared plus 2. Negative 3 plus 5 is a positive 2. We need that negative out front still, squaring the 2 plus 2. That will give us a negative 4 plus 2 equals negative 2. So if we plug in negative 3, we get out negative 2, which is going to be down here. And if we mirror that over the axis of symmetry, we're going to get negative 7, negative 2. And we need to pick one more point that we can plug into our equation. So I'm going to pick negative 2, because that's still getting pretty close to our points that we've already picked. So if we plug negative 2 into the equation, we're going to get negative 2 plus 5 squared plus 2. Simplifying, we get negative times 3 squared plus 2. So we're going to get negative 9 plus 2, which equals negative 7. So we have negative 2, negative 7 for our next point. And if we mirror that over the axis of symmetry, we're going to get negative 8, negative 7. And then we just draw our lines, connect the dots. Our parabola is facing down, and that's what we wanted. So that's how we're going to graph in vertex form. So our last example starts with an a value of 1/2. And although that might be a little scary, we may have fractions in our lessons, so it's very important that we practice. Positive 1/2 still means that our parabola is going to open up. Our vertex is at hk. Another reminder, our h is negative by default, so that means that our h in this equation is a negative 3 and k is negative 2, leaving our axis of symmetry at x equals negative 3. So the first thing we're going to do is plot these two things. If we have x equals -3 as our axis of symmetry, and then we have our vertex at -3, -2. So our next step is to pick a new point. So I'm going to pick -2 because that's close to the axis of symmetry. So if we plug -2 into our equation, we're going to get 1/2 times x plus 3, times -2 plus 3 squared minus 2. Simplifying, we get 1/2 times 1 squared minus 2. 1 squared is just 1, and 1/2 times 1 is just 1/2. So we get 1/2 minus 2, and that equals -1.5. So our -2 gives us back a value of -1.5. And if we plot that on the graph, -2, -1.5, it's going to be pretty close to the point we already have. And then if we mirror that over the axis of symmetry, we will get -4, -1.5. So since that one seemed to get pretty close, the next value I'm going to pick is a +1, just to see if we can get out of this area to see where our graph is headed. So another color so you don't get lost. If I plug in a +1 into my equation, I'm going to get 1/2 times 1 plus 3 squared minus 2. 1 plus 3 is 4 squared times 1/2 minus 2, and that equals 1/2. 4 squared is 16 minus 2. 1/2 times 16 is 8. 8 minus 2 equals 6. So if we plug 1 in, we're going to get a 6 out. 1, 2, 3, 4, 5, 6. And if we mirror that over the axis of symmetry, 2, 3, 4, 1, 2, 3, 4, we are going to get a -7, +6. So then we draw our parabola, connecting the dots. We said that our graph was going to open up, and it did. Notice that we have a 1/2, and we know that a value of a, the absolute value of a, is less than 1, which is a fraction or a decimal. Our graph gets, or our parabola gets wider, and notice that it did. So it looks like we're on the right track. So as a review, remember the equation for our vertex form is y equals a times the quantity x minus h squared plus k. We know that if our a value is greater than 0, our parabola is going to open up. If it's less than 0, our parabola is going to open down. If the absolute value of a is greater than 1, our graph is going to be narrower. And if the absolute value of a is less than 1, our parabola is going to be wider. Two other things. Remember, the coordinates of the vertex is hk. So it is a -h in the equation, but it is a +h for the vertex, and that is very important for you to remember. And then the equation for our axis of symmetry is x equals h. And that will conclude the lesson.